Okay, so we're moving towards deriving the relationship between the object that has information about curvature and the object that has information about the stuff that does the curving. And so we've already looked at this and its properties, and now we're trying to derive this. And in so doing, we want to derive a certain relationship between different permutations of the Riemann tensor. So we'll derive some of these relations, and then we'll motivate others. It's just too cumbersome to go through all of the calculations, but we want to derive these relationships that are due to Bianchi. So we have, let's write these curvature tensor components, and then we'll see that if we add certain combinations, we'll get 0, and from that, we'll ultimately be able to derive this kind of thing. So dCABD plus, let's add the terms that are positive, C ED gamma EAB, and then we have the negative terms D gamma C AD in XB plus gamma C EB gamma E AD, and let's consider our C DBA. Right, so we're going to bring this here, this in the middle, and this to the end. So a different permutation, and this becomes D gamma C DA with respect to XB plus gamma C EB gamma E DA minus derivative of gamma C BD in XA plus gamma C EA gamma E DB. And the last one is we did CDBA, CADB, and we have CBAD, and this is D gamma CBD with respect to X A plus gamma CEA gamma EBD minus D gamma CBA in XD plus gamma CED gamma EBA. So now let's consider adding. So we want to consider adding terms that give us a 0, and then we'll consider covariant divergences ultimately, and that will have to be equal to 0 as well. And so we're going to see the objects that satisfy those criteria. So if we add these three, we see that RC ADB plus RC DBA plus RC BAD is going to equal to 0. So let's see that. So let's see if we can see this. CAB, I have CBA, but connection is symmetric. So this is with respect to XD, and so is this. These are the same thing. So this thing and this thing cancel out. CEAD, EBA, again, symmetric. So this cancels with this. CDA, CDA CAD, again symmetric with respect to XB, so these are canceling with these. CEB, EDA, and it should be EAD. But again, symmetric, so these cancel out, and these should cancel CBD, XA. So this cancels with this, CEA, EPD, symmetric. Again, this cancels with that. And so we see that, in fact, we get 0, and so we'll appeal to this relationship, which is due to Bianchi.